Hello everyone. I wanted to walk you through how we do grain size estimations using the software known as ImageJ. This is going to be part of your lab report for Unit 1. So I wanted to show you pretty quick how we do it on our steel samples. So I've downloaded ImageJ. This is a free software, a photo analysis software that is pretty handy. It has lots of fun tools. We're using it primarily just to measure grain size. We will also use it in the future to estimate area fractions of different phases in the next lab. So once you have opened it, I have loaded one of the steel images I took onto my desktop. You see here, this is a 1045 CD at 100 times magnification. You see we have our nice ferrite and our pearlite regions. So we're going to use the lineal intercept method to estimate average grain size. So I'm going to go ahead and open this file on my desktop into ImageJ. Here you go. So the big part of using the lineal intercept method is you draw a line of known length on your image. You then mark every point where it crosses a grain boundary or it intersects a new phase, and then you divide the line length by the total number of intersects, and that is your average size. So first thing we need to do is we need to tell ImageJ how far a line is in this image. Thankfully, we have our scale bar, which you should hopefully have on every single image. So I'm going to use the line tool. I'm going to draw a line that is the length of the scale bar. Like so. Then you go to Analyze, you go to Set Scale, and ImageJ is saying the line I just drew is 99 pixels long. I know it has a known distance of 10, and the unit is micrometers. So we have a scale of 9.9 pixels per micrometer. So I'm going to go ahead and hit OK. Now I'm going to draw a second line just across my sample, like so. And then I am going to put a little dot every time it intersects a boundary between our ferrite and our pearlite regions. Because pearlite does not have a completely well-defined edge, this can be a little tricky, but I would just like you to do your best. So we're going to put one here. So we have 1, we have 2, 3, 4. I'm going to say this is one region, 5, 6, 7, 8, 9, 10, 11, 12. Say, let's write the tip there, 13, 14, 15, say 16, 17, 18. So we have 18 points, and if you go to Analyze and Measure, ImageJ will tell you the length of this line, so 85.9 micrometers long. And if we go to our fun calculator, 85.9 divided by 18, an average grain size of 4.7 micrometers for our 1045 CD. So that's one. And if you want, you can do another line. So let's draw another line, say a vertical one here. This is 1, so we'll say 1, 2, 3, 4, 5. Let's say 6, 7, 8. Let's say this is all 1, 9, 10. All right, so we have 10 there, and if we go to measure, now analyze and measure, the line is 64.74. Divided by 10, that's pretty easy math. 6.475 micrometers. So you see we get a slightly larger grain size if we take a second one. So what I would like you to do for your report is to do this at least, I believe, 3 times on our samples. And this is the grain size you will report in your lab report. That's it. Thank you.